Okay, so for the first little bit here, we're going to review exactly what we did last time. I feel like most of you got it as far as how to draw a perfect cube in space with 1 point perspective. So feel free to just try to do it, see how far you can go if you can remember all the steps. I'm going to talk through each step, so if you don't know what to do next, just draw with me. But I want to just check your knowledge, see what you remember. So whenever you're setting up a perspective drawing, the first thing that you need to know is what? You do need to know your viewpoint. That's broken down into two separate things. Eye level's the first, thank you. And I know from the drawing I'm doing today that we're drawing stuff below our eye level. And so I'm going to put my eye level near the top of my page. I want to be precise, guys. Precision becomes pretty important when you're laying out a perspective drawing. And so I'm going to measure down 1 inch from the top of my page and 1 inch from the top on the other side so that I know that my line is going to be perfectly parallel with the top and bottom of my page. I'm not just going to throw my line on there and draw. I want to use, like, the nice thing about a piece of paper is it's been machine cut with perfectly right angle corners. So my verticals are always vertical and my horizontals are always horizontal, and that'll help me in my drawing later. So I want to stay with that. So first thing we need, and I'm going to put these steps on here. You can write these down. The first thing you always need to know to set this up, we need to know our eye level. We need to know where the horizon is. And so we just did that. In order to know my perspective or my point of view, there's one other thing I need to know. Do you remember what that one was?
Wasn't that where the art?
What's that?
Where the art?
That's next. It's related to that.
Wait, what are you asking?
So in order to know, so perspective is all about knowing what point of view you're looking from. Right now we know how high our eye is, but we don't know the other half of knowing where our perspective is.
It's like the lines out the middle where you're standing. I don't know.
It's an imaginary line that represents where we are this way, right? I could be standing here, I could be standing here, I could be standing here. We have to decide where we're standing. We call it the line of sight. And so I'm going to call it LOS. Okay. And to set that up, again, I want to be precise. And this is a 12 inch sheet of paper. It's 9 by 12. And so I'm going to put my line of sight right in the middle just because it's easy. So right at 6 inches, I'll make a dot. And then right at 6 inches on my horizon line, I'll make a dot. Why am I not using the top of my page? Because the tape's in the way. But this is a perfectly parallel line too. And so now, if I connect these two dots, this creates my line of sight. So this is the eye level right here, and this is my line of sight, my LOS. Okay? And once you know those two things in 1 point perspective, we also know the third thing now. What's the third thing? We do know the point of view. We don't know our station point yet. We know our vanishing point. In 1 point perspective, the vanishing point is always where the line of sight and the eye level meet. That'll change in 2 point perspective, but this is going to be our vanishing point right there. I'm going to put VP. If these acronyms are, is acronym the right term? If these acronyms get confusing, I can write it out longhand, but my handwriting's bad, so. Anyway, so now we need to know station point. So, and the station point is going to be somewhere along the line of sight, but theoretically it's where our feet are, right? And I'm just going to put it down here near the bottom. So that's our station point. I'll draw little footprints. So our head is up here, our feet are down here, and we're looking into this scene. And the reason why we need to know where our feet are is because this is where a square in perspective actually becomes a square. So a horizontal square, like if you hold a square up to your eyes, right at eye level, a square is going to appear like a flat line, right? Like if you have a square sheet of cardboard, but as you come down, you're gonna start to see more and then more. And by the time you get down to your feet, if you put that piece of square on the floor, it's actually a perfect square. And that's why the logic for this works, okay? Otherwise it wouldn't make sense, trust me. So anyway, we have our vanishing point, we have our station point. And this is what you need to do every time when you're setting up a drawing. You have to have these solved first, and then you can create whatever you want and it'll work out. So the next thing that I need to know, anyone remember? It involves this one. This is my 30, 60, 90 triangle. And your cone of vision is going to be 30 degrees in either direction of your station point. And this is really how we see. Like everything within this 60-degree cone of vision that lays out in front of you is more focused. But as your fingers move away, they get more and more blurry, right? And you can actually see, I don't know if you guys know this. Has anyone had my sculpture class in here? We talk about this in sculpture because if you wiggle your fingers, everyone do this for a second if you can. Take your fingers, and if you wiggle your fingers so you can see it, but keep your face forward, see how far behind your head you can go before your fingers disappear. And it's actually behind your head, right? Our total vision is more than 180 degrees, but our focus is about 60 degrees, right? So when I'm looking right here at Mateo, I can't tell what's going on over here. I know Claire's sitting there, but I can't do anything more really than just recognize that there's something going on, right? So the cone of vision is just what appears in focus. Everything outside of that gets a little wonky when you're dealing with perspective drawings, okay? So if I was drawing like an illustration for a children's book and there was a big castle or a city scene and there's a knight walking down the street and there's buildings and shops, I'd want to make sure that entire scene fits inside my cone of vision. Because if it's coming way out here, it's going to look really weird, right? And so I would draw it in here and then crop in, right? That's when it would be, I guess, practical. Really practical to know. Okay, so we have our station point, we have our cone of vision, so COV, cone of vision. And then the last thing we need, anyone remember what that one was? And to do that, I have to extend my horizon line further off the page. And that's where the big page underneath becomes important. So I'm gonna extend that out. And again, this comes back to the idea of, there we go. This is basically a vanishing point for 45-degree angles. And down here at our station point, if you have a perfect square, it looks like this, right? And so we have our corners A and B and C and D. So lines A and C and lines B, D go to the vanishing point, right? They're 90 degrees. They go straight to the vanishing point. So they're 90 degrees from the bottom of the page. Whereas down here at the station point, this line from B to C is a perfect 45-degree angle. And so we need to know where that hits the vanishing point. You can do this a couple ways. A little shortcut. I mean, you can try to draw the line all the way, or you can just get your triangle in the right place, use your ruler. All we really need to know is where does this line hit my eye level. And so all I really need is this line right there. I don't need to draw the whole line. I need to know this point. This becomes my measuring point, right? Because I'm going to use it to measure 45-degree angles in perspective. Good so far? And once you have this, you can draw anything in perspective, as long as it deals with 90-degree angles and cubic forms and rectangular forms, okay? So we're going to draw a cube, a perfect cube in space. And just want to make sure everybody can do this before we move on, because then we're going to do a checkerboard, which is basically 64 cubes in space, right? So let's make sure you can do one before we try to do that many. But again, or as a quick reminder, so I'm going to put measuring point there, number 6. Okay. So we have all of those things figured out here. There's my station point. Here's my cone of vision, my measuring point. And then the logic of perspective in 1-point perspective, there's our 3 logics that we have to, if we follow these rules, everything will look right. Has to do with the lines. What happens to vertical lines? They're the same. Yep. So if it's vertical in your drawing, or in real life, it's vertical in the drawing. Okay. Horizontal lines. Same. And then we have orthogonal. It's with an O. I've pronounced it orthogonal like my whole life, but it's orthogonal. Orthogonal lines, what happens to them? Yep, they go to the VP. So if you know that, so in my little map here, this is a horizontal line, they'll be horizontal, but these are orthogonal lines because they're going away from us. The lines are going away. Does that make sense? This is like a drone view of whatever's in here, right? This is like the map looking down. Anyway, we'll show you. But first thing we need to do if we're going to draw a cube is to be able to draw a square, right? Perfect square. So I'm going to pick a spot anywhere within my cone of vision. It gets a little tricky if you try to draw a cube really close to the line of sight or really close to the eye level. And so I'm going to move mine out somewhere, maybe like right out in here somewhere. And so to keep my line vertical or horizontal, I'm going to use my square. And it looks like I'm using centimeters today because that's what I have here. But I can make a square that is, let's do 3 centimeters. So it goes from 1 centimeter to 4 centimeter there. Fair enough, right? And then I've got to come over and do another 3 centimeters for my vertical. So 1, 2, 3. It doesn't matter as long as it's a perfect square, right? Because if you have a perfect cube, you have to have a perfect square for the front. And then from here, I don't really have to measure anymore because I know that my horizontal lines stay horizontal. Thank you. Way to go. So I bring that over and my vertical line stays vertical. And so now I have a perfect square. Okay, next step, we're gonna take our orthogonal lines back, and I want you to draw all of the orthogonal lines, even the ones that are hidden. We're gonna draw through, okay? So, got our pencil here. It's really important here, guys, to kind of learn, like if your pencil's sharper, sometimes you need to get in a little closer with your ruler. And sometimes if your pencil's a little dull, you leave a little extra space. But make sure that your pencil starts right at the corner and ends right at the vanishing point. If you get careless so that your lines start like being slightly off, it really messes with things. The more precise you can be, the better these drawings turn out. The other thing I'd say is draw light. We don't know where this line is going to end, so I know I'm going to be erasing this, at least parts of these orthogonal lines at some point. So don't draw them heavy. That's why we're using a 2B. It's soft, but it's also easy to erase, but it's hard enough that you can be precise. And so the problem that we have with this drawing right now, the perspective problem that we need to solve, is we don't know where the back of our cube is, right? We got to find the back of our cube. And so we go back to this little diagram. If we can figure out the line from B, corner B, to corner C, then we can figure out where the back of our box is, right? So right up here, if this is the map, this is corner A and corner B, but we don't know where C is. C is somewhere down there, right? This is the bottom part of our box. It's like the footprint, it's the floor. And that's what our measuring point gives us. Every line you draw from a corner to this measuring point will tell you what a 45-degree angle looks like in this scene. So if I go to line B, or corner B right here, and I go to my measuring point, where that intersects with this line here, that also happens to be where the back of the box intersects too, right? And so now I found where my corner C is. It's right there. And then based on logic, I can finish my cube. Because vertical lines stay vertical. So I can go for my back corner. And I can go right up until it hits the top. And there's that corner. And then horizontal lines stay horizontal, so I just have to stay horizontal. Be as precise and as careful as I can. My pencil's starting to get a little dull, so I'm going to make sure that it's right on the dot. And then extend it across to where it intersects. And vertical lines stay vertical. And so that'll come down till it hits there. And if I drew very precisely, these lines, right, that corner here and this corner here should be pretty dang close to exactly on the same horizontal plane, even though I didn't draw a line. And look at that. Sweet. Doesn't always work out if you get a little bit off, but there's the back of my box. And that is a perfect cube in 1-point perspective. Okay, so make sure you can do that. I'll come around, see what questions you have. But those are the steps to get a perfect cube.